Okay, so for the next week, and you'll notice that we are going to have a Thursday quiz instead of a Friday quiz. That's just how things fell. But for the next week, we are going to talk about oblique triangles. What did we define oblique triangles to be yesterday? Triangles that do not have a 90-degree angle. So we have right triangles and non-right triangles, okay? And oblique triangles are our non-right triangles, okay? In chapter 4, you showed me that you are awesome at solving right triangles, okay? And so then yesterday, you went through an activity that basically took an oblique triangle and you discovered ways to solve it not involving right triangle. Okay? So when we are given an oblique triangle with a certain amount of given information, we can use the law of sines. The law of sines is not going to work every time, and then you went through what the law of cosines. Okay, it's either the law of sines or the law of cosines, but we have to be given a certain amount of given information. And there's 3 sets of information we're going to have to be given each time. Okay? So in your notes, go ahead and copy down the law of sines formula that you went through on that activity yesterday. Please keep in mind, just like always, and it's always been like this, capital letters are the angles, lowercase letters are the sides. We can only use the law of sines when we are given these 3 pieces of information, either angle, angle, side, angle, which is what we're going to look at today, or side, angle. Okay. Now, that third one sticks out to your eyes a little bit. I know. It's a special case that we're going to spend Monday talking about. And because of the letters and their arrangement, I'm hoping that it does stick out to you so that you can remember that it's the special case. Okay. But today we're going to focus on the first 2 cases. If you are given 2 angles in one side, in whatever order it happens, you can use the law of sines formula to figure out the other 3 pieces of information. Okay. What's nice about the law of sines formula, I know that it's 3 fractions that all equal each other, but you really only need a pair of them at a time. You're going to set up a proportion. Okay. You're going to set up a proportion based on the information that you are given and what you are trying to find. Okay. Like I said, today we're going to focus on these 2 cases. Monday, we'll look at the side angle case. It is not something that you looked at in Algebra 2, okay? We actually have the possibility of having no solution, 1 solution, or 2 solutions to a triangle. So we'll spend Monday talking about that and really digging into what, why, how of all of that, okay? So I'm really going to only go through 1 example of 2 angles and a side because it's a pretty straightforward process. Your homework should not be overly strenuous. So you're always going to be given 3 pieces of information. In this triangle, ABC, angle A is 32 degrees, angle B is 50 degrees, and angle C is 18.7 centimeters. Good morning. Welcome to class. angle drawn anywhere in that given information? No. In order to figure out what given information we have, like the order of it, we need to draw a picture. Okay? We also need to draw a picture so that when we get our answers, we can make sure that they actually seem like legitimate answers based on the given information. So it does not have to be accurate. I think most of my triangles look like they're equilateral, but we know that this is not an equilateral triangle. But just let's get an idea of where things fall. So we know that angle A is 32 degrees, angle B is 50 degrees, and side C is 18.7 centimeters. Remember, the sides are across from the angles. Now, it looks like we have two angles with a side in between. So we say that this is our angle side angle scenario, okay, which we know is something that we can use the law of sines for. Okay. So step number 1, get out your calculator and make sure that it is in degree mode. You're going to use your calculator for this chapter. Woo! It's only been like 3 weeks. How do you use it? Okay, are you in degree mode? All right, what is the first thing that we can solve for? We have 2 angles. Let's find the third. What should our 3 angles add up to be? 180 degrees. So angle C is going to be 180 minus 32 minus 50 degrees. What is that? What is it? What do you say, 98? When I was growing up, there was a band called 98 Degrees. Isn't it? And I say that and you have no idea. It was in the day of like all the boy bands. You probably have heard of NSYNC and Backstreet Boys, but 98 Degrees was in that same area. Okay. All right. So now that we have angle C, okay, let's go ahead and set up our proportion. So if we want to find side A, then we can set up the sine of 32 degrees over side A. So the sine of A over A. What are we going to set it equal to? What pair are we going to pair it up with? The C's, because we have both of them. The sine of 98 degrees over 18.7. Okay, you now have a proportion to solve. I'm going to take it step by step for you just so you can see it, but you're going to solve enough of these to where you probably don't need to always show your work, okay? But since we have a proportion, we can cross multiply. A times the sine of 98 degrees equals 18.7 times the sine of 32 degrees. So in your calculator, you can punch in 18.7 times the sine of 32 degrees. Make sure that you either hit equals or close off the parentheses before dividing the sine of 98 degrees over to the other side. But you can punch this in all in one swoop. And we're going to round to 2 decimal places. What'd you get?
10.01 rounding.
10.01. And since side C was labeled in centimeters, I'm also going to label side A with centimeters. Okay. In a problem, I need to see your picture. You need the picture to determine whether you need to use the law of sines or law of cosines. I get that we're just starting the process, but we will want that for when we have more options. And then I need to see your setup with your answers. I should not only see A equals 10.01 centimeters. I at least need to see the setup and your answer. You can do things in your calculator. I have no problem with that. But I need to see how you set it up. Okay? Especially if something went wrong, we need to determine, did you set it up wrong or did something go wrong with your calculator? But I can't help you work through that if you don't show your work. Okay? Now, we need to solve for side B. So we know that we need to set up the sine of 50 degrees over B. Technically, we could pair it up with either group, either the A's or the C's. But which one is going to give us a more accurate answer? The C's. I am going to encourage you to use as much given information as possible. If we use a rounded answer in our problem and then round that answer, we might have a little bit of error. So use as much given information as possible when you're setting up these ratios. Okay. So I'll let you work through that one without me showing you every single step. What do we get for side B? 14 point what?
47.
47? Okay. When we're working with our triangles, the biggest angle should be across from the biggest side. The smallest angle should be across from the smallest side. Is that happening in this triangle? Okay. If your biggest angle is not across from the biggest side, you probably should go back and look at your work and see if something, okay? Because there should be that relationship there. How many of you recall, whether it be really well or just vaguely, doing this last year? Okay. Good. In your homework, this is as intense as these problems will get this weekend. You're either going to have angle, side, angle, or angle, angle, side. No matter what, I'm going to give you two angles, find the third, and then you have two proportions to set up. Okay. Now, there is one more thing that we can do with the law of sines, and something that you didn't really go through in that blue sheet yesterday, but there is an area formula that we can use from the law of sines. How do we find the area of a triangle? 1/2 base times height. Okay. Well, not all the time is it convenient to find the height of a triangle. Okay. Like if I asked you to take this triangle, draw the altitude, and find the altitude, it would take quite a bit of work. Okay. So we do have some other options that mathematicians have worked through patterns to help us save some time. Okay, I don't know if you remember from first semester, we had a matrix that could help us find the area of a triangle. Remember that? That was pretty cool. So here's another formula. The area of an oblique triangle, instead of having to find the height, we can take 1/2 times side times the sine of the angle in between. So I'm going to give you a chance to just write this down along with, we have to know SAS, side, angle, side. And then once you're done writing, I'll talk about it more so that you can understand what it is. Okay? Okay, so really, if you know the first formula, then you know the second and the third. Okay, you wouldn't necessarily need to have all of those written down. But if you have angle side, so two sides and an angle in between, then we can take 1/2 times the product of those two sides times the sine of that angle that is in between. And that's going to take care of our 1/2 base times height without actually having to find the height of the triangle. Does anybody need more time to write? Yes.
So does it only work with two sides and one angle?
Yes, it only works for side angle side. So maybe we have to like find a little bit more information and then use the formula, but you have to have side angle side in order to be able to plug these in. Okay? So like over here, we couldn't use it until we found side A, and then with this side angle side, we could solve for the area. Okay? So here we go. Here is a triangle that I would like to find the area of. So go ahead and write down the given information. Okay, so here again, it would be a good idea to draw a picture to make sure which information you have. So angle C is 102 degrees, side B is 52, and side A is 90 meters. Okay, so do we have two sides with an angle in between? You betcha. So, since we have side angle side, then we can find the area by taking 1/2 times the side times the side times the sine of that angle that's in between. So then you can just type in your calculator all at one time. What did you get, Nathan?
What?
What did you get?
2,288.87
And what would we label?
meters
Square meters. Since we're talking about area, we're talking about 2 dimensions, so we need that square unit label. All right. This is all your homework's going to be. Solve a triangle, find the area. Okay? Really easing into it. Okay? So we have about 8 minutes left in class. So either you are going to do 1 or 2 problems from your homework, or you're going to get organized and fill out your retake form and turn it into me so I can help you start that retake process. Okay? I will allow you to check out your tests starting today, so you can use the weekend if you'd like. So you're either starting your homework or you are checking out a test. Okay?